Today, I am going to discuss the assignment problems. Assignment means how to allocate the manpower with the jobs. Which man to be allocated which job so that the overall time will be minimum. This is the assignment problem. In this case, we'll use the Hungarian method for solving the assignment problem. The problem to be solved here is there are 5 jobs 1, 2, 3, 4, 5 and 5 operators 1, 2, 3, 4, 5 operators. The same operator will take different time to finish the job. This operator will take 5 hours to finish the job 1 and same operator will take for this job 4 hours. In this way, for each job the time required by the operators are noted in the matrix. This is a 5 by 5 matrix. So again I am explaining. Suppose 6. What is 6? 6 means if the operator 3 is allocated the job 4, then the time will be required 6 hours. Say 5. What is 5 hours means if the operator 5 if the operator 5 is allocated with the job 4, then the total time will be required 5 hours. In this way, the time required for all the jobs by the different operators are noted in the given matrix. What you have to do? You have to find out which job to be allocated with which operator so that the overall time will be minimum. This is the problem. So here we will use the Hungarian method. Why Hungarian method? That I will discuss in next videos, because this is actually a linear programming. That also I will discuss how it is a form of linear programming, but still it is solved by Hungarian method, not by transportation method like that. But today I am going to discuss how to solve these assignment problems by Hungarian method. This is the balanced transportation problem. Balanced means 5 by 5. That means the jobs required, jobs are 5, number 5, and operators are also 5. If it is 5 by 4, then it will be unbalanced assignment problem. And how we'll solve it, that I will discuss later on. And as this is the case where we are dealing with the time required, that's why we'll minimize this problem. This is a minimization problem. If this type of problem is given with profit, then it will be a maximization problem. That also I will discuss later on with a separate video. So today I am going to discuss a balanced assignment problem by Hungarian method. How we'll do it? What is the process? Okay. Now there is a space limitation. That's why I will do this problem on the same matrix. So what is the procedure? First, what you will do, for each row you will identify the lowest element and subtract that element from all the other elements. This is the first step. Again I am repeating the first step. What you will do, for each row 1, row 2, row 3, row 4, you will identify the lowest element, in this case the lowest time, and subtract from all other elements and form a revised matrix. I am doing on the same matrix, as there is a limitation of space. I am not able to erase it, that's why I am doing on the same matrix. So here is the lowest element for this row is 4. That's why 4 is being subtracted from all the elements. So if we subtract 4, then you will get 1. 5 minus 4 is 1. 6 minus 4 is 2. 8 minus 4 is 4. And 6 minus 4 is 2. 4 minus 4 is 0. First row operation has been completed. Now for second row, again identify the lowest element and subtract from all other elements. In this row, the lowest element is 4. Out of this, 8, 7, 7 by 4 is the lowest. That's why 4 is to be subtracted from all the other elements. So 4 minus 4 is 0. 8 minus 4 is 4. This is 7 minus 4 is 3. And 7 minus 4 is 3. And this is 1. Okay. Third row. Again find out the lowest element. This is a coincidence. Again the lowest element is 4. That's why 4 is to be subtracted from all other elements. That's why that will be 7 minus 4 is 3. 7 minus 4 is 3, and 4 minus 4 is 0. 5 minus 4 is 1, and 4 minus 4 is 0. Now take fourth row. What is the lowest element? In this case, the lowest element is 5. You check, the lowest element is 5. That's why 5 is to be subtracted from all other elements. 6 minus 5 is 1. 5 minus 5 is 0. 6 minus 5 is 1. And 7 minus 5 is 2. And 5 minus 5 is 0. For the last row, the lowest element is 4. That's why 4 is to be subtracted from all other elements. So 4 minus 4 is 0. 7 minus 4 is 3. And this is 4. This is 2. This is 2. And this is 4. The first step has been completed. Similar way, in the next step, you have to find out the lowest element, or in this case the time, for all columns and subtract from other elements. See, for first column the lowest element is 0, and you have to subtract 0 from all other elements of that column. As if you subtract 0, the element will remain same. That's why it will not change. For the second row is also the lowest element is 0. If you subtract the lowest element from all the other elements, it will remain same. That's why it will not change. For third column also, the lowest element is 0. That's why it is again, it will not change. But for fourth column, you see there is the lowest element is 1, and 1 is to be subtracted from all other elements of that column. That means 2 minus 1 is 1. 3 minus 1 is 2. And 1 minus 1 is 0. 2 minus 1 is 1. And 2 minus 1 is 1. And for fourth column, the lowest element is 0. If you subtract the lowest element from other elements, it will remain same. In this way, the row operation and column operations is to be completed, as I have already mentioned. After completing this, in the third step, what you will do, you try to pass horizontal or vertical lines so that minimum number of lines will cover all the zeros. Again, I am repeating what you will do. In the third step, what you will do, you will pass the minimum number of horizontal or vertical lines, minimum number of lines, not at random we will draw the lines, the minimum number of horizontal or vertical lines so that all zeros are to be touched. See how I will do it. See, we will draw this line to cover this zero. The line is, say, this. All zeros have been covered. Next, suppose you draw this line. You have to cover this zero. It is not covered. That's why this is another line. And you have to cover this zero also, the remaining zeros. So you should draw a line over this in this way. Line. I think 1, 2, 3. Another zero is still there. Another zero is still there. That's why you have to draw another line, horizontal or vertical line. Keep in your mind, the line should be either horizontal or vertical. You cannot draw a diagonal in this way, or half line. It is not allowed. In this way, you have to draw the minimum number of horizontal or vertical lines so that all zeros should be covered or touched. I think all zeros have been covered. No zero has been left. How many lines required to cover all the zeros? How many lines? You count it. 1, 2, 3, and 4 lines. The 4 lines required to cover all the zeros. Now, the condition is if the number of lines is equal to the order of the matrix, then you have reached to the optimum. You need not to do anything further. But if the number of lines is less then the order of the matrix, then you have to proceed further to do next operation. So in this case, the order of matrix is 5. In this case, the order of matrix is 5, but the number of lines required to cover all the 0 is 4. That means the number of lines is less than the order of matrix. If the lines required is 5, then you should stop here and the final allocation required to do. But as the number of lines less than the order of the matrix, you should proceed further. Then what will be your next step? The next step will be, what will be your next step? The next step will be, you find out the lowest element from the elements which have not been covered, that means which have not been attached. From the remaining elements, you find out the lowest one, that means out of 4, 1, 3, 2, 1, 1, the lowest is 1. And what you will do, you will subtract that lowest element, from all the remaining elements, and you will add that element to the junction point. But you need not to do anything to the other elements where it has been passed. So this is your next process. So next process, again I am repeating, from the remaining elements which have not been touched, you find out the lowest element and subtract from all the remaining elements, and that lowest element you add to the junction point. That means here you have to add 3 plus 1. Here the lowest element is 1, that's why you have to add to this junction point 3 plus 1, 3 plus 1, and 3 plus 1, and this is also junction point, that is plus 1, and you have to minus from the remaining one, minus 1, minus 1, minus 1, minus 1, in this way, minus. This is the process. If you have any doubt, I am again repeating. What you will do, you will find out the lowest element from the remaining elements. Here it is 1. Here 1 is more than 1 places, but you will select 1, and you will subtract that from the remaining elements. These are the remaining elements from where you have subtracted it, and from to the junction point you have to add the lowest one. Junction point means here is a junction point 3 plus 1, and this is also a junction point 3 plus 1. So here is also a junction point, but you need not to do anything over this. You need not to. That will be your next matrix. Again I am repeating, due to crisis, due to shortage of space, I am doing on the same matrix. You will do it in your copy in a separate matrix. Okay, so I am noting the values after computing. In this way. How it will be? This will be 1. It is better to note down by red one. Okay, this is 1, and it will remain same. That's why it will be 0, and it will be 4. 3 plus 1 will be 4. This is a revised matrix. You note 4, and it will be remain same. That is 1. It will be 1. It will be also remain same. It will be 0. It will be remain same. That's why it will be 2. It will remain same. That's why it will be 4. But in this case it will be 4. 3 plus 1, it will change. It will be written as 4, and it will remain same. 0, 0, and 3. 0 and 3. It will be 3. The revised one, it will be 3. 3 minus 1 is 2, and it will be remain same. That is 0, and this is 0, and this is 3, and this is 0. 1 minus 1 is 0, and this is 1. 2 minus 1 is 1, and this will be remain same as it passes over it, and this is 0, 0, and this is also 0, and finally this will be remain same 0, and this will be remain same, nothing change 1, but 0 plus 1, that's why the revised one will be 1. This is plus 1 and this will be 0 remains same 0 and this will be 4 remains same. In this way the revised matrix will be drawn and again I am repeating, you will do it in a separate page or separate matrix you will draw. Again you will pass the horizontal and vertical lines so that the minimum number of lines cover all the zeros. The minimum number of lines will cover all the zeros. So check it how we will cover it, and the number of lines, say how many lines, this 0 are covered, say this and 0, this is also a line to cover this 0, and then 2 0 0, these lines are also required to cover this 0, and this is also required to cover 0, and this is also required to cover 0. I think these are the minimum lines by which you can cover all the zeros. You can check that less than this number of lines it is not possible to cover all the zeros. You can check it from your side. Is it possible to draw lesser than these numbers to cover all the zeros? I think it is not possible. The one zero remains same. 1 2 3 4 5. Sorry, and again you have to check that is also to be none. 0 0 0. Achha. It is better you draw this line 0 0 0 this, and it is not required. Better it is not required, and you draw in this way. This way require a bit trial. In this way you can check it. That is sufficient. This is maximum number of zeros. That's why there is no rule, but you try to practice it how to cover all the zeros with minimum number of lines. Now you see all zeros are covered. Here this is also covered. All zeros are covered and zeros are in this one. How many lines require? 1 2 3 4 and 5. 5 number of lines are required to cover all the zeros. 5 number of lines are required to cover all the zeros. And what is the order of the matrix? That is also 5. That is also 5. That means we have reached to the optimum. We need not to do the same operations further, as I have already discussed. Now the next part is allocation of job with the operations. Okay. Now it is better to draw a fresh matrix, otherwise it will be a bit clumsy. Okay, just I am checking 1 2 3 0 0 0 4 2 1 1 4 4 0 0 1 1 0 0 1 0 0 0 3 3 0 4. Okay, now I am erasing this matrix and write fresh one for the next process of allocation. For the next process of allocation. Okay. Yes. For the next process of allocation. Now this is 1 2 3 4 and 5. And 1 2 3 4 and 5. The value was, what was the value? 1 2 3 0 0 1 2 3 0 0. This was the last matrix. 0 4 2 0 4 2 1 1 1 1 4 4 4 4 0 0 1 0 0 and 1 and 1. This is 1 1 2 3 4 and 0 3 0 3 3 0 4. We have reached to the optimum, as I have already discussed. Now the part of allocation. How will allocate it? How you will allocate it? Okay. See, in this row only 1 0. You will put the allocation on 0. As here is a 0, there is a zero, only 1 0, you must allocate here, because you must allocate here. Otherwise, if you not allocate it, then this job will miss. It should also be completed. That's why you should allocate. But here is more than 1 0. You can, there is option to do allocation. That's why I have fixed this allocation. As we have fixed this allocation, you cannot further allocate this one, because that means this indicate the job 2 will be allocated to the operator 1. Hence operator 1 cannot be allocated to any other job, and you have to put allocation on 0 only, no other elements. In this way, now see, if you move, then if you, here is 1 0, you must have to put your allocation, otherwise the job 4 5 will be left out to complete the job 5s, and you can only allocate on 0. That's why we are putting allocation here. As there is no other zeros, it has already been crossed, you must have to put allocation here. That is the logic. And as we have put here allocation, that's why you cannot allocate here, because the fifth job is allocated by the operator 4. If you suppose, see that if you not allocate it, then where you will allocate? There is no other 0 remaining. That's why you must have to allocate here. That's why I have put the allocation. Now move to the next. Now you can move from the first row to the other rows. Next, you from first row 1 0 is left here. You have to give some allocation to this job. That's why you have to take this, and you cannot, as you have allocated this, that means first job is to be allocated by fifth operator. The fifth operator cannot be allocated to another job. That's why I cross this 0. Next, this is already completed. Now go to this. Now you can put allocation here. Only 1 0 left. That's why you cannot allocate 0 further in this way. And this is the last one. That means what will be your answer? Your answer will be first job. I am writing first job. There is a space problem. The first job is to be allocated to the first job is to be allocated to fifth operator. First job is to be allocated to fifth operator. Second job is to be allocated to first operator. First operator. Then third job is to be allocated to third operator. Third job, these are the job, is to be allocated by third operator. Fourth job is to be allocated by second operator. And fifth job, I'm writing here, fifth job is to be allocated by fourth operator. Now see 1 2 3 4 5 job, and this is 1 2 3 4 5. In this way you have to allocate. Now see what will be the time required. For calculating the time required, you have to go to the original table where we have started. So if first job is to be allocated with fifth operator, the time required will be 4. Then if second job is to be allocated with first operator, second job first operator, the time again is 4 hours. And third job with third operator, again it is 4 hours. Fourth job to the second operator, the time required is 5. And fifth job to the fourth operator, the time required is 6 hours. That means total time requires 8 and 9. 8 plus 9 plus 6. That is total time required will be 8 plus 9 plus 6. 8 plus 9 plus 6 is equal to 23 hours. 8, 9 and 23 hours. That is the answer. 23 hours. What is the timing? 23 hours. Okay. So what will be your answer? The answer will be the first job is to be allocated to operator 5. The second job is to be allocated to operator first. Third job is to be allocated to operator third. And fourth job is to be allocated to operator second. And fifth job to be allocated to operator 4. And the time you have to put from the original table. That is, I already mentioned, and the total time required will be 23 hours. You can check by changing the allocation, then you will see definitely the total hours required will be more than this, because this is a special technique that is called Hungarian method, by which assignment problem is solved and the minimum time required by this allocation is calculated. Okay, thank you. Thank you. In this way, you can solve the assignment problem by a Hungarian method. In my next problem, I will show how we'll solve the unbalanced assignment problem. Unbalanced means the number of jobs and number of operators or may not be same. Is differ. How we'll solve it, that I will discuss later on. And I will also discuss, instead of minimization problem, here I have shown with the help of time required. If the profit is given, then how will maximize the profit? That problem I will discuss in my different video. And finally, I will show the formulation of the assignment problem, algebraic formulation of the assignment problem, and why we do not solve by linear programming like simplex method or transportation method, but why we are solving by Hungarian method. That also I will discuss in my that video, respective video. Thank you. If you have any question, please write it to the comment box. I will definitely give the answer. Thank you.